So, what I'm gonna show you today, it's a little bit different. It's more my approach, what I like, and I'd like to see more discussions about in the blockchain. Okay, I see blockchain as a database. Okay, and one approach, and there is two platforms that's really I really like it. I believe you can extract most of them. One is Hyperledger, it's open source, and IBM use them. And the other one is BigChain from MongoDB. Okay, they really have really good approach, and they both are really interesting. Okay, I'm gonna show you how it works and Hyperledger for now. Okay, because you have more private blockchain built in Hyperledger. You have a very good documentation. Really, it's a really good tool to build. Okay, and I have some examples. I'm gonna discuss to you about the transaction workflow, and I set up a blockchain environment in my machine. And you're gonna send some requests. I'm gonna do some transactions in the blockchain. I'm gonna see how it works. Okay. One thing it's very difficult to find someone discussing and explain when blockchain works is how is the database works. Okay. For the most important, we have here the world stage or stage DB. Okay. Just show how is the current state of the ledger. Okay, and all previous transactions are recorded in the blockchain file system here in the blocks. Okay, this is the old version of the world state ledger. Okay, so what and how it works. Okay, so this is smart contract here. Is implemented using a code chain. They use Hyperledger and BigChain. They use another terminology. So a smart contract is a code chain. Is how this network or how this ledger are supposed to work, need to work. Okay. So and you have you're gonna have an application. Then you're gonna invoke a smart contract. Okay. The smart contract you're gonna use some functions to retrieve information from the world state DB, most of them. You're gonna select some data from here. You're gonna send your operation, and then you say, okay, let's approve this transactions. Okay, so because when people people just explain the blocks, okay, how the blocks works, but however, for the application to understand how it works, the blocks, you can say, okay, the blocks are immutable, okay, but for you get the data, you won't get the data from the blocks. You want data from the world state ledger. Imagine, for example, when you explain this transaction in Bitcoin, you see a lot of transactions saved in the block. But okay, how much money do I have? Okay. So you have a state DB that you're gonna hold. Oh, I have 15 Bitcoins, for example. Okay, you don't need to run for the entire blockchain every transaction to say how much Bitcoins I have. Okay, so I'm gonna show you, and this is a good transaction. Okay.
So Mauricio, you are saying that the world ledger or world state is a summary of the history, right? So the world state is like a snapshot.
The current state, the snapshot, they call materialized view. So if the idea, for example, if you pick since the first block, the Genesis block, run all transactions again, you're gonna have the state DB. Okay, so the state DB is guaranteed. You can say the information I have here is guaranteed by all the blocks. Is here. Okay, so every time you you search for information or every transaction you do on StateDB. Okay? You're gonna do it on StateDB. When you commit in transactions, we're gonna save the transaction, they're gonna be the older versions here, you're gonna be here. Gonna be to this blockchain. So yeah, here is it's like the logs. You're gonna record the logs here. So immutable source of truth, they call. So
the transactions occur, they're captured on the state database, and then at the cutoffs, that forms a block that gets loaded onto the blockchain, like a copy of that.
yeah, it's, for example, you send a transaction, okay, and okay, this transaction is valid, it's okay, you're gonna commit to StateDB. Okay, so this transaction you send, you're gonna be recorded on the blockchain, file systems. Okay, it's the same way a normal database works. The same idea. You save the log, but what happens in the database? Someone after you have a lot of transactions, you just delete the logs.
So someone asked me this question once, and I didn't know the answer. If I were to submit a transaction, for example, to the Bitcoin blockchain,
Okay.
and I decide before the 10-minute cutoff that I want to cancel the transaction, will it get recorded on the blockchain? My understanding, based on how you're explaining this to me, is if I delete the transaction on the state database before it gets backed up onto the blockchain.
Yeah, you're gonna record both transactions.
Oh, both would get recorded?
Both get recorded.
How would the blockchain ledger know that the transaction was there to cancel?
Okay, yeah, I'm gonna show it. Yeah. Okay, I'm gonna show. So the Bitcoin environment is way different from this one. Okay, but the idea here, every block actually is just a checkpoint. The exact term is a checkpoint for a bunch of transactions. So, and the consensus mechanism will say, okay, you have all this bunch of transactions, everyone's agree, it's okay, so let's create this new block with this set of transactions. Okay, but the StateDB is not not always the same. I'm gonna show. I have now in the last slide I have exactly the same way how it works. But yeah, here you say if you pick Hyperledger or Big Chain, okay, when you send a transaction, it takes 1 second to spread this transaction for the entire world. It's not 10 minutes. It's really fast. It's 1 second. It's the entire world. You can set up. Okay, so and the blocks is you can say is more transparent. Okay, this is true. It's immutable, and you can reconstruct using this one. That's the idea. Okay.
So my other question is, there's really no time then, based on what you're telling me, where the state database and the blockchain database are out of sync.
Yeah.
I mean,
it's kind of,
like a
yeah.
second, but not really. Like, my concern would be, since the state database is not immutable, can I make changes to that
No,
that are not reflected in the
no.
blockchain?
The state database is replaceable. Okay. This is the transaction log. This is the blockchain file system. Okay. But it happens something. A lot of transactions are gonna be in the blocks, okay? In the StateDB, you're gonna every time it's changing. You have versions of the StateDB, so it's changing. You say the transaction, you change a value from 8, for example. I have 8 marbles. Now I bought a new one. When I buy a new one, you go there and update. No, Mauricio has 9. Okay, when you say that I have 9. This transaction, when it's committed, it's already sent from the block. Okay, it's already sent from the block. Just that. So actually, like I say, you're gonna write this transaction in the block to commit the StateDB and invalidate this one. You don't have this lag. It's simultaneous. Okay, when you have this one. Okay, that's the idea. So you need to think this one. When you get this data. When you're selecting this data and picking this data, you always pick the StateDB, okay? And how this is stored, okay? And this is a very important one. okay, is this one. It's really hard to see here. Okay, so how we store the data in the database is you call a level DB. It's a key value pair. You have a key and a value. Here I have a key, marble 1, value. In this value I can have some properties. I have asset name, owner, and date, for example. This is how we start. So this is a JSON file. This is a JSON file. So I have a key and a JSON file. So what's the problem with this level DB? This is the default. Okay, this is the default database. This is it's work with Ethereum and it's work with Bitcoin. So what's the level B? What's the problem? You cannot query, you cannot search. For example, I want to see my key is my marbles. Let's say I have 1,000 marbles. I want to see which marbles belongs to Mauricio or which marbles belong to Ed. You can't do this because you cannot query. You can only retrieve information using the key. This is a really, really big problem. That's why it's.
What do you mean by the key? Which key are you talking about?
The key, marble 1. Key, marble 1, or the key that could be in the Bitcoin. Each Bitcoin has a key,
Right.
so you can only retrieve this information by key. So okay, I wanna see. I'm gonna show you an example using cars database. Okay, what's the problem? I cannot retrieve information. I wanna know how many blue cars I have. You cannot retrieve this information. How you can do this? You can go for SADB for every keys. You go one by one, retrieve information one by one, parsing this information, create your report. This is not good. Okay, so that's why Hyperledger and BigChain, they are creating this CouchDB. CouchDB, they are integrated. So they are putting the state DB are replicated in a non-SQL database, and you have a really powerful query capabilities. So this changed. That's why Ethereum doesn't work cannot work for companies. Bitcoin doesn't work for companies because you cannot query, you cannot do a lot of things. Okay, and when you have this CouchDB, okay, when you have this SQL database, a non-SQL database together, it's a replica from the state DB, and now you have a possibility to query this data. Okay, so if you want to do a commercial, you need to use Hyperledger or BigChain. That's right.
Is possible for you to edit, like make a change to the CouchDB that's not reflected in the other
No.
database? Not?
No, you can't. Because this CouchDB is going to run in a Docker, in a very secure environment that's a replica from the state DB. And this CouchDB, which is, let's say, this non-SQL database, they use CouchDB for Hyperledger and MongoDB for BigChain. It's a non-SQL database, okay, it's working in JSON. It's a replica, gonna run in a Docker environment. So either way, it's just a read, you can only read the query.
Oh.
You cannot write that. Because the state DB is the real one, that one's a replica, you can query there so you can make a lot of transactions, okay? But this is, for example, for the user, when you're using this one, it's transparent. You don't see this one, okay? But this is important, okay? So you have it's a key value. If you take a database class, right? You saw how SQL database works. So you can see how difficult it is to represent a business logic here. Okay. Okay, if I have, what's the problem here? For example, owner, you just right here, Jerry. Okay, but where Jerry, for example, and then I have another channel, another smart contract, another chain that holds the owner and, for example, your address and documents. Okay, so how do I know if Jerry really exists? You don't have this foreign key together. you need to do this in application level. Your application should guarantee, or your code chain smart contract. You're gonna query the other smart contract to return the owner to see if this match, and then you can insert. But you need to do this by hand. It's not the database that works. So it's really, really complex to do this one. Okay, that's why I don't have a big system running in a blockchain environment. You just have very small applications. Okay, so same idea. Okay, and how? So when you have a CouchDB, you can create a complex rich query, for example. And then you have a cars. I'm gonna show cars. I wanna return. Okay, I wanna see how many cars belongs to Mauricio, or how many Ford cars I have. You can return this one for the database. When you have a normal blockchain without this other database, you can't do this. You cannot just query this way. You need to query everyone. Like, for example, if you work with CSV file, you need to read line by line, find what you want, and keep this in memory. It's really hard to do. Imagine if you have millions of transactions, you do one by one. Okay, so, and this is how a transaction works, actually. Okay? I have a client, I have application, and I want to send a transaction. Okay? And then I go to a peer. It's the end point. If you pick this is the first layer, for example, if you have the environment, the top, when you connect to a submitting peers. Okay? Okay, what you're gonna do? You're gonna simulate and execute. This is the payload smart contract. Okay? So I'm gonna verify the dependence, the state updates, and what's happening here in a blockchain, in private blockchain environment. When I create this smart contract, I can set up some endorsement rules. And I say, okay, for this kind of transaction, I want to peer 1, peer 2, and peer 3 endorse my transaction. It's not every node. It's just endorsement nodes, and you can specify which one. For example, what you can say, I'm selling cars, and we have two companies, each one is one company. Okay, so each company should agree, each node, each peers belongs to a company, and each company should agree with this transaction. If they agree, they are gonna create this hash for you, and gonna return. So you go to submitting peers, you're gonna say, okay, you need to send this transaction for peer 1, endorsement peer 1, 2, and 3. And then you're gonna send 1, 2, and 3. Then they're gonna execute the smart contract. They go to state level DB, check your information, you're gonna simulate and say, oh, the new result is gonna be this one, for example. Okay, Mauricio bought a new pearl, a new marble. Okay, so update now that Mauricio has 9 marbles. You're gonna send for these 3. You say, they're gonna say, okay, how many? It's one more, right? So how many he has? 8. Let's execute again. Let's execute my contract. Now he has 9. So the result is gonna be 9 with my signature. The 3 return for the submitting peers. You're gonna return for you. This is gonna be your transaction. And then you submit for the concession service. You're gonna be submitted to here. Okay? This service, you're gonna see, they're gonna validate, yeah. So it's endorsed by the T1, it's okay. Spread this information, spread this transaction for every node, for all transactions keys. And here you have more peers that are not endorsed. And they're gonna spread these transactions. When you spread these transactions, you verify the endorsement is okay, the dependence is okay, apply the state updates. Update the state B. So your transaction is okay, it's submitted, it's on the block, it's okay. So you have this endorsement, the endorsement policy, they're going to run smart contracts, going to return to you, validate, send the consensus and spread the mechanism. Okay? It's very easy. Okay?
So Mauricio, under my understanding for the system itself, so basically when we talk about relational database, we get that normalized tables that actually
Yeah.
that guarantees the efficiency and effectiveness of the databases, right?
Yeah.
But actually, you mentioned that there is some kind of like a referential like integrity problem
Yeah.
associated with this database. And actually, we are storing the data by transactions, not on the not the tables, normalized tables,
Yeah, exactly.
because it's not a relation model, is it right?
Exactly.
So that is still causing some kind of like bottleneck, or like, is it like still efficient on that way?
No, it's not efficient.
It's not efficient.
It's not
So it's only purpose of this immutable property
Yeah.
characteristics that we want to use for this.
Exactly.
this database.
It's not efficient. Actually, GIS is really, really fast, okay, but it's not so fast as a normal database. Okay, you have some checks, you have some integrations. One good thing for them, this is a distributed database. Okay, it's a distributed database. What's happening? A lot of servers can be shut down, but your network is gonna still be working. So you have some fault tolerance. It's quite interesting the way you do it. And you have this problem with just consistency. Your table is not normalized. For example, each smart contract is one ledger. Okay, if you have two smart contracts, you have two ledgers. Okay, you cannot, if you execute one smart contract, you cannot update a value in another smart contract. You can only update values in your own ledger. You can only read the other ledgers. Okay, so this is the presentation. I'm gonna show you how it works. It's not so complicated. Okay, but this is very important to see how is the workflow. You send the endorsement peers, they validate, they execute the smart contract if it's right, and sign for you. In return, then you pick all endorsements, policies, for the 3 peers approve. So I follow this policy, so send to the consensus, and they're gonna spread for everyone. Okay, and why? So here, so when you send here, when you execute here, each smart contract, I'm gonna read from state B and say, my state B is version 2. So the new value gonna be 9. Okay? You're gonna return for me. So version 0, version 2, new value 9. Version 2, new version 9. Version 2, new version, in the hash. When you're gonna send here to apply, if I change the version of my state B, for example, and then you spread and you apply this transaction, okay? If I wanna send this again, this double spend problem, you say, hey, now when you update for 9, now the new version, the state B version, is gonna be 3, not 2 anymore. It's a new version. When you're gonna send this transaction again, you say, hey, this is not the same version, so this transaction is gonna be rejected. That's the way you validate this double spend problem that you don't have, and you are not calling this way. So, because imagine you're gonna spread for the entire world. Until you get in Japan, China, you're gonna take some seconds, and another transaction may change this value. And they say, oh no, it is not the same one between when you did, while you did. In transaction database, we do one thing you call is lock. When I do a transaction, begin a transaction, we lock the row or lock the table until you finish it. But it does not happen here because imagine I'm seeing a transaction here in the United States, you're gonna be sent for the peers here in the United States. When you're in China, you're gonna be sent for the peers in China. When you're gonna spread this one, they can be a problem.
But actually, it doesn't guarantee the avoiding the
No, they guarantee. The consensus service is gonna do this one. Yeah, the problem is, okay, what happens if I send the transactions almost the same time, right? Actually, they have a timestamp. For example, if I send this before, if I say change it from 8 to 10, you say send it to 8 to 9, right? So they're gonna say, hey, when you're gonna update, microseconds later, they say, no, this is not the same version anymore. That's why you have this consensus mechanism. For all distributed databases, this is not a new thing for Bitcoin blockchain. It already exists. It's for replicate database. You have this problem. If you just look for this literature for replicate database, you have all these versions control with how they deal. They can deal with this in a very good way.
So is consensus service is a one which is based on a distributed version, or
Yeah.
is it kind of like centralized by some kind of admin?
Yeah, no, you can have, for example, this consensus. You say, okay, everyone have the same vote, so okay, but you can say no. The boss, for example, if I own the company, for like the CEO has a better vote, right? So if you say no, this is the right, this is the wrong. So and you can have authority, who has power more than others, to say this is the real one, not the other one, or you have this consensus mechanism that you have more people that okay, it's the vote. In the way they did here, for example, in practical Byzantine fault tolerance, I sent a link to read, right? But they say in here you need 2/3 of the servers or the network working if they're gonna approve. But this is not a problem because the consensus mechanism is really fast here. So it's only gonna happen if we both send a transaction for the same assets, for the same key, almost the same time. You go what's happened because you are the server is gonna execute in alone. They don't know when they say I execute this one just. So that's you have the endorsement first. You're gonna work, okay? So this is a transaction flow, okay? The website, and this worked very well, okay? You have the assumptions here. Okay, so your client, you send for your endpoint where you connect. You're gonna send for the endorsement peers. Okay. And they're gonna validate and sign the transaction and give you back for the application for SDK for the first level, the submission peers. Okay, and then you're gonna endorse the peer, verify the signature, verify the execute transaction. You're gonna say, oh, okay, this is okay. So let's update. Then you update your response. Okay, you have everything here is documented. You can take a look. Okay, so the actual something application. Okay, and then you order in server, it's okay, and then send again. You're gonna spread for everyone. Okay, so they verify. So when you send for the peers and validate the transaction, so every block will be delivered for all peer channels. So they ensure the transactions, the blocks, validate the endorsement policies if fulfilled. So okay, endorsement policy. What you did, the peers should 1, 2, and 3 should approve. They approve. So this is the final result of transactions. They ensure that there have been no change to the ledger state for read set variable since the read set are generated by transaction execution keys. Okay, transaction in the block are tagged for being valid or invalid. So that's it. When they are going to broadcast, you say this is the final transactions, the new results. They're going to validate. Okay, since you start the transactions, did you change anything? No, so it's okay. Because not you, maybe someone the other part of the world could change, right? You need to do this again. Okay, you have a really good. The documentation here is really good, and they update the ledgers. Okay, so let me show this. Okay, so you have a glossary. Okay, here you have a lot of things here. What's the endorsement policy? What's endorsement? Okay, you can take a read. I sent this website for you. You have a lot of things how it works. They have everything here is from this website. I take for you. Okay, I didn't bring a block. I sent a document with Adam, Andre, and Ab about this big chain. Right? They have very good workflows there. I didn't show here too much thing, but okay. In the Hyperledger, they have this composer. You can play this online, but I install everything in my machine. I make this work. Okay. So, this is Fabricar chain. The Fabricar blockchain. Okay, this is a ledger. This is gonna run in Hyperledger, and how you can guarantee for them in a normal database, a transaction database, what's happened? Use your application to input, to change your data, everything, right? However, you can go straight to the database, connect straight to the database, and send an update request or delete request by hand. Okay, so if you have you don't have a user for this one, but someone in the IT system, or IT department, they have this admin passwords, and they can change some value. Nobody knows, and delete the logs because they have, and the logs, they delete the logs and not the stored anywhere because they delete that log again, so they cannot find. Okay, and you cannot trust for them. And actually, you do a lot because you have a lot of problems in your ERP systems, and a lot of times you need to fix the data, and then you go directly straight to the database and change the data straight there because it's wrong, right? So in the blockchain, right, this doesn't happen. Why? Because for change the state B, you can only change the data if you have a specific function to do that. Okay, so you cannot just execute a random query in the state DB unless you create a function to execute a random query. You cannot delete a key if you don't have a function to delete the key. Okay, so why this is more secure? Because you control which kind of transaction or which functions you're going to be executed on your key, on your ledger. So nobody can go straight there and change the values without execute one of your functions. Okay, so this Fabricard Go is the entire chain code for this ledger, for this blockchain Fabricard. It is Fabricledger, is cards. Okay, so I have all the documentation here. So, and here I define my structure from my ledger. So my ledger, you're gonna have four fields. I have the make, the model, the color, and who is the owner. Okay. So just here I define my ledger. How is gonna be the structure of my data? Okay. And here I define the functions I can use. Okay. I have a function called query card. Okay. And I have one. I need to pass here the cards. Okay. Then I have a function create card. So each card is gonna be a key on my ledger. Okay. So can I delete if I create a card? I say, can I delete something from the data from the blockchain? Yes, I can delete. But it's gonna be stored that I delete. That's it. For example, I create 10 cards, right? Card 1 to card 10. And then I say, oh, it was wrong because I don't have card 10. I just have 9 cards. So I need to delete this one because this is wrong information. And just you need to have you need to create a function here that is delete card and go there and delete that card. You can delete, you can change information. Okay? It's a database. The only thing, this transaction I send to the database, you're gonna be validated for the endorsers. They're gonna be approved, and they're gonna be recording the block that Mauricio delete a card. Okay, and I have this function query all cards. Okay, what's happening here? In this database, I'm using this CouchB, and then here I have a query cards that I'm querying by key, and for start key and end key. So I can have from card 0 to card 999. The problem here is not a really full query. It's not a select star from cards. If I have a card 1000, it's not going to appear here. Okay. And I have a function. Oh, change car owner. I'm going to change the owner of the car. Okay. So let's do this. Execute. It's running. And this is in a Go language. Okay, so this is my function here. Let's query, and this is an application written in JavaScript. Okay, and here I have query cars. So I'm gonna comment here. I'm gonna run this one. Okay, so in this transaction, what I'm doing here, I'm simulating, it's an application, right? They're gonna send a request for my blockchain, and gonna say, okay, query all cars. Just that. They say, okay, which car I have here? So, node is query. Okay, node here, car 0, recorder. Okay, in my ledger here I have 8 car, 9, car 9, then I have car 0, record, car, the key, right? Then this is my values, color blue, make Toyota, model Prius, Atomic, right? So this is my car. I have the car 10 here, color red, make Chevy, model Volt, owner Abby. So let's choose her car, because Abby doesn't have a car. Okay, so and I have, because I have this function query all cars. Okay, I say no, I wanna see which car is blue. Unfortunately, I can't. Why? I don't have a function for this one. Okay, can I create? Yes, I can, because I'm using CouchDB here. If I'm not using CouchDB, no, I can't do this. Okay.
So when you were defining the function query all cars, I remember you said start from
Yeah.
car.
If I create a car that doesn't belong here, it doesn't gonna work.
So how? So can you go back to the
Okay.
function definition?
Yep.
Like, I was thinking you should know which is the end key, right?
No, you don't know.
You
You don't have to. You don't have this ability. What you're gonna be? Okay. You can use like a number from 0 to 12 nines, for example. Okay. In this way, but this is not a very efficient one. Okay. We're gonna do this in a CouchDB in a different way. You have here tutorial for query. I don't have time to do this. But you can create a query. You can write, okay, once the blue cars or the cars from web, you can do this actually using CouchDB. Using you need to, exactly, because this is a database solution, but you need to use a real database for doing a real query. Okay, so let's do this. And here I have another function that is query card, right? So it's just this one. So let's query. Let's query car, or just car 10, okay? Here, this will be easier to here. So here return our response column, red, make Chevy, model, Volt, owner, add. Okay? I was trying this last night, like 3 in the morning.
So, kind of stupid question, but more to clarify. This, the CouchDB, is referencing the summary database.
No, yeah. I'm not querying the RightDB. I'm querying the blockchain, the blockchain network. Okay, the blockchain network is going to be transparent for you. They're going to say, yeah, oh, this kind of query I cannot do this. So let's do this. You're going to return. For you, it's transparent. You don't know that's happening.
So, if for instance, I sold my car
Yeah,
to
okay.
Arian, okay?
Okay.
In this database, it would now show up as Arian
Okay.
is the owner. Would I, using this, be able to search to see who the previous owners of the
Yeah.
car were?
Yeah.
Because that's
You can
recorded
see.
in the blockchain.
You
But
can
it's
see.
not included in the state database.
No,
The
this is
state only
no.
includes that Arian's the current owner. It doesn't include
Exactly.
that I was
Exactly.
the-
This is right. When you query the state, you only get the most up-to-date data.
Yeah.
Okay. When you want to know, I want to see the history, right? Okay. Let's see who is the owner before, right? You can have the history for keys. You can query the history.
So the couch. can
The couch is
query-
replica from the state.
It's the state or it's
The
blockchain
state.
or it's both?
No, it's the both.
So-
It's just the state database. When you are doing, I wanna see the history. Okay, you're gonna query the state DB, but you can say I want the history from this key. Then your blockchain you're gonna run for the blocks and gonna just because you can only search by key, and you have the history for keys.
Exactly. So this is querying which one again? The blockchain?
The blockchain, yeah, you never query straight to the database. You only query to the blockchain. The blockchain will only return the state database for you. Okay,
But I thought the blockchain can only search by key.
can only search by key.
But you can search through this on different attributes, not only the key.
Yeah, because I have a replica in a CouchDB database.
So it's querying both?
Yeah, exactly.
Okay,
So
so
it's-
it's
Yeah, it's transparent for you. When you query, actually, when I define my function,
it's picking.
you have an API to do this one. For example, for who you're using, you don't know. It's transparent for you. It's transparent.
Okay, but technically speaking, it's picking which one and
It's all because the CouchDB you're gonna be a replica for a state DB. So you're gonna be always the most up to date data for you.
but that doesn't include all of the transactional history.
No. You need to send a specific function to return the history for
So
this
it goes
key.
first to the couch DB, says, okay, you don't have this information, then goes to the blockchain and searches by key.
No. It's another function. It's a key.history. And when you say key.history, he already know that I want the history from this key. So, and you're gonna return
Can
one
you
for
go back
So
to the
the
slide
query you're
which
actually-
you
Yeah.
showed?
Yeah, I showed you.
So that
The query that you're actually typing in here
It's
is
always up
different,
to date.
So it'll know for a fact like which source to go to.
Actually, it's this
So-
one here.
yeah.
Here.
So-
You have a state DB, and you have key history index.
Right.
Okay, so because you're not querying, because one thing, I'm gonna query all cars, I'm gonna query a car. Okay, you just have the most up to date value.
So
So-
basically, the couch DB is like index file, the set of index file.
Yeah, actually, CouchDB is gonna be. It's gonna be here. It's a replica from this
So
one.
like replica, but it does have index.
Yeah, you have index,
So,
and they say,
so
oh,
using this index file, you can actually go to the block
and
chain
retrieve. Yeah,
and retrieve data whatever you want.
exactly. You can retrieve. It's transparent for you. They're gonna say, okay, I want the history for all chains in this key. You're gonna send this. You're gonna use this key history function. They're gonna say, oh, I know where each block is. So
No.
every transaction that's changed this key, I come here and I can return the version because you can return all version for state DB for that key. And then you can say, oh, it was this ledger, then come for this one, and who changed this one for you? You can retrieve this one.
And this is defined by how you query the system, how.
Yeah, it's depending on information. And you need to write you have an API to do this, and you need to write a function to do this,
Okay.
right? If you doesn't have, you can't query. Okay, that's the idea. But you can query. Okay, just let me.
Mauricio, I don't think that's all. I think.
Yeah, it's very-
I think I
okay.
need to see some visuals for this.
Okay,
Hold on, I'll just draw this one.
okay.
So assume this is I don't know,
Okay.
blockchain, right?
Right.
And then you have transaction 1, I don't know, 09X
Okay.
ABC ends in 1. Then you have transaction 2, I don't know,
Yeah,
whatever. So this is the hash, right?
yeah. It
So
doesn't
are you
matter.
saying, when you say transparent, are you saying that this copy of the blockchain transactions is replicated in what you call this couch database, where I'm able to extract different attributes from the hash, like, I don't know, brand of the car?
No.
So
No,
then what?
No, it's not.
That's
Then
not.
what do you
No,
mean?
it's not.
forget the hash is a transaction.
Yeah.
But like I said, let's see. The ledger, from the ledger, you're gonna be like a Excel spreadsheet. You have columns and rows. Okay, each row gonna be a one key. The question
When you
is,
say
okay,
one key, do you mean this or
now
something?
one key, one card. here, okay, my ledger here, okay, I just follow, I have here, I have 10 cars in my ledger.
Yeah.
This one, okay, I just query one, okay. When you query the ledger,
Yeah.
you can say, you don't query the transactions, you
Right.
query the ledger,
Yeah.
okay. When you query the ledger, you're gonna be, okay, for each car,
Mhm.
I have one line in my, but what not showing here, for example, internal they have, oh, this is ledger version 1,
Yeah.
okay?
Yeah.
But I want to see the history, so I want to see this ledger for this key, car 10, this is version 0, and then you're going to return then the version. Then here I have the version 1, version 0, all transactions that change, all version from this ledger
But this
you
is
can retrieve.
But this is already in, I guess.
Just the update
This
data.
example you're giving, it's already in like, I guess, human readable format, right? So I'm just trying to tie back to like how
Yeah. So yeah.
transactions are posted.
Yeah, you know, for example, in usual way, you're never gonna query a transaction.
In what?
You're never gonna query a transaction. You don't need to. The transaction is storing the data in the
Yeah.
file system, right? And then I have, okay, before that transaction, I have this version. This was my data,
Mhm.
and this transaction changed my data for a new version. And you
Right.
have control of this all version.
Yeah.
It's like, for example, when you're writing a dissertation, every day you write something, you save for a different name, right? Version
Yeah.
1, version 2, version 3, right? So when I say, okay, how was my transaction in last month? And last month was this version.
Yeah.
And going, oh, yes, look like this. Okay.
I guess I'm having trouble, I know you're referring to a database, like, I don't know, like an Excel file, right, that you
Okay.
have, you know, you have a table, you have 3 different
Okay.
fields here, and then transaction 1, you
No,
know.
no transaction.
Well, like,
Car key 1,
Observation
key
one,
2. Yeah,
whatever.
but not transaction. The key, the assets, right?
okay.
So
yeah.
you have this, for example, you have car 1 and car 2, for example, okay? Let's say car 1 is Andrea and car 2 is Ed,
Yeah.
okay? And here you have a version here, okay? Say today, right? So, and for example, I want to see the version for yesterday. You have here another version for yesterday, and okay, car 1, car 2, which was the owner yesterday?
Right, so that's what you're doing.
Yeah, but you don't have, you don't query, it doesn't matter the transaction.
don't, yeah.
You don't have the transaction.
Yeah, but then how do you, so this is, let's just call this an output for now.
Okay.
Right, this is the
Exactly,
table.
that's the output.
So what is the input? Because I guess I'm a little bit confused as to what is the input, because this is what
Yeah,
a
okay.
user would enter,
So,
right?
Yeah, I just query, right?
Yeah.
So let's do input. I have here invoke, right? So let's create a new car, right? Because my user can create a new car. So let's create a new car. I need to find. So change car owner. Oh, here. So so let's create a new car. This is the input. Okay.
Okay.
Your application, this is a transaction. Your transaction
Yeah.
gonna be this ledger, okay, or this blockchain, execute this function, create car, okay, and with these attributes, the key and the values,
Oh,
okay. So when you send a transaction, you're gonna have the car 11. You're gonna be a VW, gonna be a Fusca, blue, and I am the owner. Okay? I save it, and now I'm gonna node invoke. This is how your application gonna work. So you're gonna send this one, and they're gonna say, okay, expect identifier.
Is there a way to query the system and find out, like, when you made this entry?
Chain count request file. 1, 2, 3, 4.
Yeah. But you
Fine.
have to, like, define that as a queryable thing beforehand, right?
Yeah, you're gonna send this car, right? So how was this one? Oh, I create a car, right? So car 13. This is was working. No. Oh. Jeez. Okay, okay, target. This is one. Is here. I take. Okay. Here. So this is the result. So I send this transaction. This is transaction. So you're gonna send. Okay, create a new car. You're gonna when you're in a software, you're gonna open, add a new car. So you're gonna create a new car. You're gonna say, okay, car is a Chevy, Volt, Red from Nick, and okay. When you click OK, you're gonna send for a database for blockchain, right? So you're gonna search for. This is transaction ID, the hash. Okay. The transaction proposal was good, so the peers endorse it, right? So then you're gonna send, okay, successful send proposal, receive for proposal response. Yes, okay. Then you're gonna send transaction for the listening, and they committed the change to the ledger. So they committed. It's already recorded in the blockchain. Okay, it's really that fast. Okay, and then you can query again. Okay, let's see if our car. Okay, and then you can say, okay, which car is car 11, right? So let's from here, and then you query, right? So you just query. Query. Query, right? Query car.
Was it 11 or 12?
Oh, 13, right?
13,
Yeah,
yeah.
so, yeah, that's perfect because you see, you don't have car 13, right? So, we now have car 13. So, this is perfect. It's working. Oh, here. So, when you query, okay, who belongs car 13? Yeah, car 13 is a red car, a Chevy Volt, owned by Nick, right? And then you can, for example, let's update this value. Let's set this. Ben is the owner, right? Which car do you have? Okay, so, and then here, let me show right here, this one this time. So, and here I have a request that until here, right? So, change car owner from car 13 to Ben. Okay. When I send for my application send, they're gonna change. Was good. So this is the new transaction. It was committed. Okay. So my state DB, like for example, I have index for okay. Who was the first version, the version 0, right? Was Abby or Nick, right? It was Nick. Now the version 1. Ben, right? So let's query here. Oh, now it's Ben. Okay. The database is working. Okay, and how does this work? Okay, let's say why do you want to see? The question is okay. You understand why do you want to see the history? You need to because you need to design this function, everything. Okay, I want to see the history to see any alterations. But why? Then they need to build these functions.
How many EPs do you have in your user? Endorsements?
Endorsements, yes.
Here.
Yeah.
This is you can do whenever what. It's
But
your
in your
policies.
cases,
In
how
my
many?
case,
Yeah.
I believe
And
I don't know.
Can I see those actual returns of each individual EPs to get the consensus?
I believe you can.
Yeah.
You can. Because here, for this invoke, here you are using, this is the application. For example, when I build, for example, I want to build an app for blockchain. It's this one, invoke.js. You can do this in Python. Okay, you have a chain for Python or everything. But you're going to need to send this request. This is the cars. But the result, then you're going to be here, right? So here you have this API, who's going to return for you everything. It's native. There is a lot of things that's done in the network. You don't have this data right away. It's not so easy because the application level is often you need the other users. You're going to be admin users, to work with this one, but I really don't know. I need to take a look in the documentations or something to do this one.
So those endorsement peers are something that you, like, when you were just creating this example.
When you create the smart contract, your chain code, you're gonna define what is the endorsement policies that you're gonna use. Okay, you're gonna say, for this smart contract, I need, I have like, what you could do, for example, I have a bunch of companies, a consortium, right? And for this kind of, and I have like will be like one audit firm, like one of the big fours, and they own their own node, and they validate this transaction. So you can send your chain code and say, okay, every transaction should be validated for the peer EY, for example. Then peer EY gonna run because why? They control that node, that peer. So they know that, oh, the code is here, it's safe. So no exchange that code without a node. So if I validate this one, you can say, oh, this transaction endorsed by the.
So, but in the example you've created here, right?
Okay.
The endorsement peers that you have, are those, since you just created this right now, like you just created a new record, are those nodes that are somewhere else that are online? Like they have to be online, I'm assuming.
Yeah. They must be connected on the.
And if, what happens if for whatever reason all of your endorsement peers happen to be offline?
You need to be a contingency for this one, right? It's your policy. What you gonna is your policy. What you gonna do? Okay,
So if you want to operate on the network, you have to maintain.
no, but it's your policy. You wanna say, okay, what's happened if my main, for example, let's say that they are doing distract systems for the Walmart, right? What happens if Walmart is offline? Walmart is supposed to is the most trusted peer, right? He's the most interested. And Walmart gonna like they own the blockchain. They say, okay, if my peers is offline, right? I control the network because it's my network. If I am offline, what's gonna happen? Let's stop the transactions until I get online again, or let's if 5 other peers validate, it's okay. It's your policy. You build this one. Okay, that's why you need a governance for blockchain.
Do you know what peers you've outsourced to on this example, or maybe?
Yeah, I have 3. I have 3 peers running. That's why my computer really is taking serious risk right now.
Can you go back to your slide?
Okay,
I just have a couple of questions.
sure.
So not that one. So this one.
This
No,
one,
no,
okay.
No.
Oh,
The
okay.
second one.
This one.
3. So
Okay.
blockchain
Yeah.
is
Yeah.
so because of those consensus mechanisms, we
No,
can
just
trust
like-
it.
just
Yeah.
like-
What about the state database or CouchDB?
There you go.
Okay. Yeah.
There is no consensus, right?
No, they're gonna be. For example, you have this endorsement peers, right?
Right.
So, the consensus, the state DB, you're gonna always represent all previous transactions.
Right.
The real estate, okay? So,
So what
they-
if someone changes?
no, they can't change because they're gonna be invalid. Right? It's really hard to change.
No,
Depend.
so in terms of blockchain, you
Yeah.
cannot change the transaction.
Yeah. Okay.
because
Yeah.
of
We're gonna
those-
create another chain. Yeah. So,
But this is just
So
a
if
piece of
you
database.
send out,
okay.
version
It just
If someone
depends.
have the privilege,
middle of
administrative
transaction,
privilege, and
change,
go there and change it.
a value, it creates version B.
And CouchDB is the same thing. It's just the index. If you change the
Yeah.
index,
No.
Would it
Yeah.
make
But
version
this
A
is in a secure environment. Not so easy to change. But yeah.
so that side is pretty much like a relational database.
Yeah, exactly. Yeah, that's the way it is. Okay, so
Right, so in order for them to transact.
GIS is gonna always
they would have to
represent
resend
all
it.
previous transactions in Q,
I know,
right?
that one is
So-
the design to retrieve the data.
Yeah. So the idea is if someone broke this chain, like a change of previous transaction, you're not gonna represent the CDB, not represent
Right,
this one.
right, but
I don't know.
I understand. So
Okay.
like if you change the data in the state DB or the
Mhm.
CouchDB, when you actually verify using the blockchain, it's not
Mhm.
going to work. But some malicious practices, someone just change it.
Okay. Yeah. I really don't know.
It happens,
Yeah,
right?
you, for example, you could manage to change something here, right? Yeah,
But
you could,
it
for
is
example,
impossible
if you
because
change
this is
something
block.
here, right? It's gonna be invalid right? So, but you have a copy software. It's really, really, yeah, I really don't know how to deal with this. But
where is the couch DB actually stored in your example in your computer or out there?
no, it's in my computer.
In your computer.
Because every peer for running GIS, you need to have GIS, then you're gonna have to be a couch DB.
Yes, so yes. What if you just change the value?
No, I can't change. I don't have access to the CouchDB. I don't have access because they run in another Docker environment with a set of keys to access because the blockchain creates this network.
Speaking, we just all stopped and manually changing the.
No, I don't have access. I don't have access because the CouchDB is not installed in my computer. It's installed in a Docker environment inside the blockchain. I don't have access.
I know,
don't
but
have
in your
access.
case,
Yeah,
you're not.
so
but
some guys maybe have access to do GIS.
access to do it.
I really
You
don't know.
change it.
Yeah, the protocol guarantee that is a replica from the StateDB. Okay, but they you need to send more GIS applications. So I didn't get this stage yet, right? So, but the idea is okay because when you are trying to explain blockchain, it always says by blocks, everything. But when you are using, you don't see the blocks. You see the StateDB. That's how you represent. You don't see the transactions. You don't see the previews. You can see the previews, right? You can send a query to get the previous one, the previous results, previous states from this, not the transactions. You see the previous history from the ledger. That's you need to understand. Okay, you don't see the transaction. Okay, but for example, in my application lab, in my application here, what can happen here? I can come here and change. Instead ban, now let's change again. Now is Abby. Okay? And run. Invoke. Here. So what's happening? Okay? I can sell this car how many times I want. Because my blockchain was designed that I can change the values for each one. What happens in Bitcoin or something? You can put some rules here in the owner. Okay, only the owner could change, update the value. You can create this. Okay, so the owner, how I know the owner is the user. Here I am using when I'm connecting to the network using a user one actually. And I can create a user app and it's okay. For change for app for another one, only user app can do this. And you're going to be designing in your chain code here. Okay, so it's not sort of okay. This double spend problem. The double spend problem is if you read this documentation here. If you already had this one, they comment here in the transaction flow. They comment okay when I'm update my StateDB ledger, I have some guarantees level to see if I not change. What's the last one here? Okay. Oh. So here, when I'm verified with my session file, see it was generated by transaction execution. This is the double strange problem. This is why they are guaranteeing here. When I'm the consensus mechanism, you're gonna say, okay, so now the StateDB version is this one, because you have this bunch of transactions is blocked. But every transaction is committed, but you block a bunch of transactions. So you can have a lot of, it's more the way the database works. You need to go to the roots, pick a book and read to understand more deeper. But they're gonna solve you a lot of problems. So the way they explain this double expand, it's just allegory, and this is not a good one. Okay, here it's a really fast. I use the practical Byzantine fault tolerance because we use this protocol that's gossip here. Okay, you have this gossip. I don't have gossip here. Oh, gossip protocol. Okay, so this is how you disseminate and create this consensus mechanism between the peers. Okay, because here I'm using practical Byzantine fault tolerance. I'm not using the other assurance method like that Bitcoin use like work of proof or proof of stake. You can use a bit of one. There is a lot of documentation here. It's really, really good. So when I start to, because on your project you are trying to build some applications blockchain, right? So I suggest you start with Hyperledger. You have tons of documentation. It really works. And I believe you have a lot of example, this marble example, you have this car example you can use, and you understand how it works. Because you need to think in application level, how you're going to use this data. You're not thinking in previous transactions. Okay, so until now I don't know how to build, for example, okay, I have this is my inventory. I wanna see my inventory the last day of the month, the last month, right? Or August 31, which was my inventory there. I really don't know how you can build this yet. You probably can. Now, normal database is really, really easy. You create a query and say, count my inventory, where the date it's all entrance and out of my inventory is less than or equal August 31. It's quite simple to do this. In this one, I really don't know yet how to do this. Maybe you can create a ledger with summarized 5 months.
Going back to your car example, like if let's say you're selling the car to Abby, and she's part of your blockchain.
Okay.
So she wants to check that the transaction is there, right, in the ledger, whatever, just for her car.
Yeah, because
She can do that, but is she also going to be able to check the transactions with your other customers?
I don't know.
Or if
No,
she can,
you have access levels, right?
yeah.
Yeah, you're
So
gonna
you can limit
determine
her
this
access.
one. For example, well, are you a owner of a car? Can see could see the other car's users? They say no, you can't. So you cannot, and you are not seeing the transaction. You say
Well, you
a
see
client
like
is not gonna
car
see the
she
transactions,
bought,
right? You're gonna see the ledger, right? The key.
The
So
attributes.
you can say you only have access to the key that the owner is equal to your user, for example. So when she enters in the system, for example, she's not seeing anything. When I sell the car and put the owner for her, okay, now she's not going to see the transaction. She's going to see when the next time she updates, she refreshes the web page or enter the system again, you're going to appear she has a car. Just that. Okay, she's not going to see the transaction. She's going to see the ledger. Okay.
So can I say that actually you can you can design any business rules that you want. And
Yeah.
just code it.
Yeah, in the
And
chain
For
code.
example, like what Andrea said, like we can just use creating another function to limit my access or whatever. So I think the most important thing is how can we design this business rule to
Right.
make everything work, because the technical side is actually not a problem. The most important thing is how we can make sure that
No, yeah, you have a technical problems, a really serious technical problem here. Right. Standard database, use when you're doing ERP system, the ERP system are building business logic process. Okay? This blockchain do not use business logic, they use assets logic. So every entry is an asset. Okay? They say each asset can be anything. That's the problem. For example, when you have a purchase to pay, you have a server rotate, you have a workflow to do. They say no, but you can say that one purchase order is an asset, right? That's a problem. Okay, it's not the same way. That's why it's quite difficult. And in this you need to have this attention. For example, you can maybe one good exercise is pick on one example for the books to design a business logic process in a database, like. And try to change this. Okay, this is not to be a more business rule. It's gonna be a assets logic. This is quite complex. Okay. The good thing here using this one, you can write these are JSON file, have a lot of capabilities, and you save are really huge, right? and how you're gonna deal, because the owner is not important here, but you have users level and how you're gonna design application. Okay, each user could change each application or each field, for example, right? I have the purchase order, then you buy, then okay, you receive the goods, okay, and then you're gonna update the value. Who you gonna update the value? Oh, you're gonna be your supplier. You're gonna update, but you need a validation, internal validation. Who is receiving this one? The pool. So how you gonna build this data shape, this data format here is the complex way. The good thing is you can have more than one smart contract. You can have one smart contract for purchase order, one smart contract for the thing. But how you gonna build your application to work with several smart contracts? Okay, you can. Each one is a ledger. Okay. So yeah, it's quite interesting. It's really challenging. But what I really want to show here is more how it works. Okay, how I put information, retrieve information. That's what I want to show. Because I know that you want to build a software or something like that. That's why I showed you. Okay, here I set up environment that works, so you can set up environment in the server. I believe the best way to do it is in the server. Okay, you need to create a virtual machine using Linux and import Docker. There is a lot of tutorials in the documentation. It's really good. Okay, and make it works. And then you can start to create this protocol. Okay, the good thing, Hyperledger now, the new version, they have a SDK working Python. So the composer to create this smart, the code chain, a smart contract, you can do this in Python. It'll be much easier. Don't need to run another language, or you can do this in Go. But the idea is here. So, and this is going to be a results. So this is no, not this one. Okay, so this is how it works. So you can send a request. You can I make an insert. You know about the SQL language, SQL Server. So you send an insert, you send an update, you send a select. It's the same idea. And you have but you have an entire network. There is a lot of rules. The question is here. Here I don't have a function to query the blue cars. So when you're doing this inventory, for example, I wanna search. Okay, like let's say I have a computers and iPads and tablets inventory, my ledger. Control every asset here. Okay, I want to select only the iPads. You need to design a function, then you can select types of iPads, laptops. Idea. You need to think in this before. Okay?
Can you share the code?
You sure?
Thank you.
Don't worry. Okay?
Thank you.
Questions?
Thank you.